Welcome back to Incremental, the continuous improvement podcast. This is the practice edition where we talk about improvements from the week and tie them back to lean principles.
Indeed.
I am Uriel Eisen.
I am Devin Bedoni.
I got a quote.
The quote for the week: continuous improvement is better than delayed perfection. Mark Twain.
Amen.
Which is funny based on what we know about Mark Twain.
Oh?
Right? Maybe I'm thinking the wrong person. Wasn't he like a terrible alcoholic and had real problems?
Maybe that's why he knew. It's like, I should work on this every day, but...
Yeah, do as I say, not as I do.
Exactly.
Maybe I'm thinking of someone else and I just threw him under the bus, but I thought that was a thing. Could be wrong.
Yeah, but basically, I feel like that's sort of these episodes are the little improvements we're making.
Yeah.
And actually trying things is better than big plans and little bit of doing.
Mm-hmm. One thing we've been finding is that the morning meeting like turns into small improvements very quickly because we are all on board and we have several heads coming up with a solution.
In a good way? I'm not sure exactly what you mean.
Yes, in a good way. That instead of kind of each one of us sort of in our own, stream thinking about things we need to improve.
That's interesting. It's almost like it's an interesting filter now that you say that, where like things that the group settles on maybe are really worth improving.
Yeah, I think that's part of it. Like hearkening back to the last episode, talking about TOC for guiding, guiding people and guiding where we put effort. It's not exactly the same, but my experience so far has been that like things that end up in the group meetings are issues that need to be solved. And we have 3 heads in my shop, with 3 heads on the problem instead of 1.
Mm-hmm.
And also we can distribute that amongst everybody's kind of labor pool easily, based on who has availability immediately. And it's very clear to everyone that it's a problem.
Yeah.
And so I've just been finding that solutions, they tend to be small things, but solutions come out of that very quickly.
Interesting.
And get, or like the ideas come out of it very quickly and then are enacted on very quickly as well.
Very cool.
Which has been nice.
Yeah. So jumping right in, we've been we added pneumatic assembly fixtures.
Yeah, we went over that quite a bit last week, right?
Yep.
Yeah.
Having issues with them. And I mean, they're all solvable, but they just take solving. And
they
basically
still need feel.
Yeah. So,
or there's no feel, and that's the issue.
I think a few things. Yeah. I think there's that. I think, like 3D printing is very cool, but it's also kind of floppy. So now once we have pneumatic actuators, one issue I didn't foresee with a longer throw pneumatic actuator that is not actuating something on a track is that the further you get away from any errors in how it's mounted or flex in the mounting is amplified into quite substantial movement at the end. And so the spring was getting inserted where one of the legs was not quite settled in the pocket for the spring leg. And so we sort of had to push them sideways with a pin to get them seated, which is an extra step with every assembly. And actually, I don't think we shipped any, but that problem didn't get caught immediately. Yeah. Because it wasn't something we were looking out for. Yeah. So that's been interesting, sort of just trying to optimize for learning there. We've been holding off on like screwing the assembly fixtures down to the table. It's literally a piece of painted plywood. So finally I was just like, we're going to start screwing things to the table. Just like do it fast. Like we talked about like hanging hooks versus just putting a screw in the wall and hanging something from it. Yeah. Like, I don't know. It's just so important to keep things flexible.
Can you just
quick
screw it to a piece of plywood instead of the whole table so it still can get moved out of the way?
I thought of that and opted to just screw it to the table because it was there, and because adding this is another problem we're really running into hard, is just space.
Yeah.
At our current assembly area, we launched a new product and we don't really have room for it on the assembly area, which was already very crowded. And so now it's sort of like, do we have one for each product line, or do we have fixtures that we sort of can move in and out, sort of like you're thinking about, or like, but then that's increased setup time, which encourages batch work, right? So like if we have an order for 2 1-inch cam buckles, 2 pin ladder locks, and 2 3/4-inch buckles, it is nice to have all of those fixtures laid out on the table where you just like do one of, two of each. The second there's any setup of like, oh, let me pull out the fixture for the cams, it would make more sense to start batching, of like doing a replenishment run of like the black cams, right? And then you have like Kanban on that where it triggers production of 10 or 20 or something. Yeah. Which is not good or bad. It's just stuff to think through. And I'm not sure exactly where we'll land.
Yeah. Interesting. Do you feel like, I guess just trying to tie this back. So you're creating defects.
Yep.
And over processing, sort of.
Yep, in the form of rework.
Yeah, rework, or like doing extra steps in to make it happen. Do you feel like you have a pathway to fix it?
Yeah, so we've been experimenting with it. It's 100% fixable. Yeah. And definitely a move in the right direction.
Is the long run plan to like make it in metal, or just like 3D print little components and bolt it down to an aluminum plate, or a mix of both?
I haven't really come up with a... Right now we added shims, UHMW tape, basically. Yeah. So that there is a physical... So that the cradle that's carrying the part into the assembly area is basically referencing the base plate instead of just like dangling out of in space 3 inches cantilevered off of the pneumatic piston. Yeah. So I think that will work. I don't really know what our long-term approach will be to this. I think what I am seeing is just like, it is very worthwhile to kind of push forward with an unpolished version, because you're gonna find things that you didn't even think about. And so just making things easy to kind of edit. And
I just added something to our quote list, but I feel like it's extremely topical right now, so I'm just gonna say it. It's a saying of one of my friends who's a contractor. It's, you can do it right, or you can do it right now.
Yep.
And it applies.
Yeah, that's great. I like that a lot.
And hopefully you don't just leave it right now forever, but sometimes you do if it does the job. And anyhow. Well, that's cool. Optimize for learning. But don't forget to actually continue to optimize.
Yeah. Yeah.
So we've been having, I think I missed or mentioned last episode, we had an issue with like a missed shipment, where stuff that was supposed to go to Anno didn't end up there. And we kind of traced it back to an issue with our job tracking slips and our board. Just that there wasn't sort of an explicit place for things that were... so I guess backing up, right now we have a column where these things land for when they're running on a machine. And then after they're done running on a machine, we have a column for tumbling. Okay. And then we have a column for like at Anno or some kind of, or laser marking or some kind of post-processing. We didn't have a place for things to land that were just like either ready to ship to the customer.
Oh, interesting.
Or ready to ship to anodize.
Okay.
And so it was all just kind of becoming this mishmash, and it was hard to pull apart.
I'm familiar with mishmash.
Yeah. And because of that, some parts that were done but hadn't been moved to the shipping station didn't get shipped to anodize because there was no way to see that they needed to go aside from remembering.
Gotcha.
And being on your A+ game.
Right.
So we came up, this is a morning meeting thing, came up with a very simple solution, which so we had the slips are on a magnetic clip.
Mm-hmm.
At the shipping station, there's a long strip of conduit.
Okay.
Just for electrical line. And we literally just like Sharpied on the conduit that like this area is for stuff to ship to the customer and this area is for stuff to ship to anodize.
Oh.
And when something is done tumbling or is done machining and is ready to ship, we just take the whole slip and we just go hang it on that just magnetically hang it on the conduit so that it's there for the shipping person to see, like, this is everything that's ready and needs to ship.
And that would have solved that problem?
Yeah, it would have.
Because I'm not understanding, how do you know that there aren't stray parts?
Well, assuming that you move the slips over when something's done machining, you have to still do that part of the job. But,
I see. The previous, okay, it wasn't like a stray, like we have a batch of 50 and 2 of them are over there.
No, it was a whole like part run.
Gotcha.
Yeah.
I see.
Yeah. We're pretty good about keeping parts together in a run. We've rarely had issues with that.
Yeah.
This was like a whole part number that needed to be included and was forgotten.
Gotcha.
And then, so now if they ship to ano, then they go back to the main board to show that they're at anodize. And then if they come back, then they go back over there to ship to the customer. So it's a little bit of back and forth, but we kind of were like, we could add it to the board, but there's not room on the board physically.
Mm-hmm.
And we think this will be more explicit. It's a little more like walking back and forth and slips in different places, but I think it's doing a better job. So tying that back to lean principles, I think it's solving waiting and what effectively is defects. I don't know.
The waiting is what?
Things having to delay longer because we didn't get them shipped.
Oh, I see. Yeah, is that a defect in time? What is that?
I don't know. It's a defect in the process.
Defect. Yeah.
Anyhow, so that was kind of cool.
Yeah, what is the lean waste of things not arriving in time? Well, I guess in time in a JIT production line is definitely waiting.
Yeah.
But for like a customer, well, interesting.
I think it's still waiting.
Yeah, I guess it's waiting. Whether they need it, or think they need it, or just want it. Either way, they're waiting for your parts.
Yeah, either way, it's something sitting that should be in motion.
True.
Yeah.
Right. It's not necessarily a person waiting. It might be the thing itself waiting is a waste.
Mm-hmm.
Yeah. Very cool. So we made some 3D printed sewing jigs. People were very excited about them because sewing jigs typically cost thousands of dollars.
Oh yeah, did you get a lot of like feedback from other people who are into sewing?
Yeah, got a few people who they're like, "Can I buy one of those?" So, but a company,
buy a 3D printer.
A company we talked to a company in San Francisco who they were sort of curious how we were doing our fixturing, and we had talked about 3D printed fixturing a little while ago. Anyway, got a care package in the mail from them, which was super awesome. It's Illy Equipment, cool bag maker down in SF. So they sent us a pretty sweet bag and a 3D printed jig that they made.
Oh, right on.
And it was pretty cool. It's funny. I don't know. It's funny that like sewing fixturing is such a specialized, almost art. But I think that has to do with the fact that the people who are often doing the sewing aren't machinists or aren't woodworkers. Like the stuff they are very, very good at is floppy.
Yeah.
So it makes terrible fixtures. And so I think maybe that's why they're so divorced. I mean, I've been in a bunch of shops where there are like brilliant mechanical people because they have to keep a bunch of sewing machines running.
Yeah.
So like there are people who are doing it in-house, but a lot of it is done by these specialized shops, but it's not really that difficult. It's interesting.
Well, there's the knowledge base. There's also just the access to the equipment.
Right. Totally.
Which like most sewing shops don't have a mill, probably.
Right. Yeah.
Or even a 3D printer, probably.
And if they do have a 3D printer, they're not CAD people.
Probably. Yeah. So
that
was
a lot
like
of things to conflue, which is not a word.
Intuitively, before you even started describing it, I was like, it's because they don't have the stuff.
Interesting. Yeah.
Not that they don't have the knowledge necessarily.
Right.
Yeah.
The first version we built was made out of cardboard and hot glue. So kind of anyone has the stuff.
But that probably wouldn't hold up, right?
That one particularly wouldn't. But I think if you used like mat board, it would not hold up if you were doing 6 months of production, but it would totally hold up if you were doing a week or two. And then you could take it to your friend who has a wood shop and be like, can you make this in white oak or something hard?
I've always been kind of curious about laser cutters and mat board and like thin cardboard.
You're basically 3D printing.
Yeah.
Right?
And
just
like
do these layered assemblies.
Or like, like packaging style assemblies with like slots and things that like link together. And you can do super cool, just like, layout fixtures and folded. I have never dove into it because I don't have a laser cutter, but it's always been something I've been like, I think we could do a lot with that kind of stuff, especially for around the shop and like tooling and storage. And
so I was at, I built out a prototyping shop for NYU's Startup Accelerator when I was in New York, and they had a laser cutter. And so I went ham with that thing. And it's really amazing what you can do. A fun little fixture I built for it. Someone wanted these coins made out of wood. I mean, basically with some logos and stuff on them, but they wanted both sides engraved. And when you flip something, you have a doubling effect of if anything is off of center. Oh yeah. And you flip it over, you're doubling the error. Yeah. And so and the wood strips that they got us, the blanks were not very consistently cut into like rectangles. I built a kinematic fixture, which basically only touched that part in X and Y, like didn't over constrain it. So it touched it in 3 points, right? 2 on the long edge, 1 on the short edge. And then when you flipped it, it touched the same points and it just nailed the tolerance. But yeah, all of these, like you could do some really cool things where you etch, like if you need a locating boss, in the next layer up, you could etch it into the bottom layer. And then it would like drop right in to locate it. And then you would glue it right in place. It was really fun and so easy because there's no cutting forces basically. Yeah.
Just throw your sheets in and go to town.
It's so tempting to get one. Yeah. I have to say. Yeah.
Maybe someday we could split one.
Sounds good.
So we wrapped up I think I mentioned we had started, but we wrapped up our new tool tag implementation and it's been super helpful. So that was the color-coded magnetic tags. Okay. New standard, non-standard, the whole deal, like we talked about. And it's been really great just to get a visual looking at the machine, and you can just the yellow versus green is very clear. So just wanted to kind of follow up on that. That's been awesome. There's some, like everything you do, like you solve a problem and then you see the next issue in the chain. Yeah. And
what are the new issues you're seeing?
The issues we're seeing now are we need to buy more tool holders because we have more we've created more standard tools than we originally had. And then wanting to have a dedicated location for non-standard tool holders to land. Right now they're kind of ending up on a bench or mixed in on the tool rack. And then also I would like to get more specific about where our standard tools end up on the tool rack. Right now we just have basically a shelving unit with a bunch of holes in it that they all drop into. And it's like very loosely organized by milling, drilling, tapping. Gotcha. And the tool tags make it pretty easy to find stuff. But I think now that we have some standards, it would be very easy to dedicate pockets to those standards so that they always go back to the same place when they're not in a machine. And I think that will just further streamline the whole process. And then have a whole area for non-standards that are like free to use basically. So
the issues you're solving, or the tool tag solved, like I'm thinking glancing at the machine and knowing what waste does that eliminate? Like what were you doing before? Is that like going up to the machine and stopping it and opening the doors to look inside, and then like sort of comparing the tool to the tag.
Yeah, you mean from V1 tool tag to V2 tool tag, or
Maybe.
tool tags in general?
Yeah. Either, both.
Yeah, I think some confusion. So mostly like wasted human potential, and then over processing of just like going back and forth on stuff and searching.
So I think the common thing there, and we've seen this over and over in our shop, and it's so simple that it just never feels like a top priority somehow.
Yeah.
Like color coding, or just making it so that at a glance you know what things are, what's happening somewhere.
Yeah.
It really changes. I don't know. It's a huge efficiency gain, I feel like.
Yeah. On the note of color coding, we are building a house, and right now we're having the framing done.
Okay.
I came home the other day and walked out to take a look at the house, and one of the guys working on it was color coding all of his screw guns and batteries and stuff.
Awesome.
And he had this cool little marker thing, and I was like, "What is that?" So I haven't actually bought any yet, but he was like, "Oh yeah, these are the bee's knees." They're called Molotov markers. There's like,
interesting. I feel like my dad just sent me.
Maybe there's like one place you can get them, but they are like alcohol paint.
Whoa.
I'm pulling it up.
Oh yeah. Maybe we should just drop them in the show notes.
Yeah, Molotov permanent paint marker. You can be, I think, a bit more precise with them than with nail polish, because they're meant for actually like, drawing, sort of.
I've been curious about whatever is being used for marking bolts after assembly.
The white,
but there's other colors, I'm sure.
I think this.
It is that.
Yeah.
Okay.
Well, maybe not this brand, but
right,
it's a paint marker.
Yeah. Okay.
Yeah.
Because it seems to be very durable.
Yeah. And we found nail polish to be pretty durable. Coolant seems to maybe take it off.
Interesting. Yeah.
Depending on what it's painted onto.
Right. The only successful application we've had is if you sandblast. Then
for
it
nail
really
polish.
stays. Yeah.
Interesting.
But it's a hassle, and especially for stuff that's going to go into the mill, I really don't want sand in the mill. So, I don't know.
Yeah. Anyway, everybody should check those out.
Yeah.
Or wait, and we'll check them out and see if they work. But it seemed like promising. They're not that expensive too. It's like $6 a pop for one.
Oh, awesome.
And I think that would last a long time.
Right.
With the amount that we use.
Very cool. Yeah, we have tool tags. We don't really change tools very frequently, but I will say I think it's a waste that they're not color coded, because at a glance you could know, like, to make new soft jaws or to make different things require switching out some tools to non-standard.
Yeah.
And then what I've been doing is using one of those the yellow ring on the start button that you printed for us.
Yeah.
To indicate like, hey, this machine is not ready, but
not ready to run standard part or production.
But it'd be really nice if it was like a red tag for non-standard.
Yeah.
So it's like, not only do I know it's not ready, and then I walk across the shop and ask Uriel, hey, why is this yellow? Instead, it's like, oh yeah, this tool's out. So
interesting. You could almost you could have a bunch of like universal standards, and then you could have other ones that were color coded to your different products. Yeah,
I've been in the back of my mind kind of stewing on how we want to do, because I think we're going to want custom tools to different products. And so I'm kind of trying to figure out how we're going to go about doing that in a very efficient way. Yeah. Everything from making it visually apparent what should be in the machine for that product, to how we're going to logistically load them into the machine and run them through the tool setter. Like, is that built into the program where it knows which pockets you're going to change? Yeah. And goes and tests, checks them, and it could even check them it could remember what they should be and flag it if it's not.
Yeah, because you don't want to change out every tool unnecessarily and have a duplicate of everything. Right. But it would be interesting to be, I don't know.
Like, maybe I say like tool 1 through 10 is like those ones stay in the machines, and then Right. Like I could break it out. I don't know. 11 through 15 are this.
It gets hard.
Like you could kind of group it. I don't know.
Yeah. I think you need to say, you'd have to have on a setup sheet, like this has 3 alternate tools, have them color coded to that part.
I thought it'd be
number or something.
Yeah. Interesting.
Just so you need to be able to way to compare like that all of the different colored ones are in there.
Yeah.
Not just some.
This has issues, but I thought it'd be really cool to have sort of like a strip on the setup tray that would magnet on next to your tool tags and would match the color of each tool tag. So you could see any mismatches.
That would be, yeah.
It'd be very cool. It assumes that you have a distinct color for each. Right. Like, I don't know. It gets tricky. Like, does purple mean a particular tool or does purple mean a tap? And you have...
I think purple would have to mean a particular... I think purple would have to follow the part number. And you might have some duplicate alternate tools where it's like this gets used in 2 part numbers. It gets a little tricky.
Yeah.
But I think it's worth continuing to think about.
For sure. Right, because it can be so laborious, or it can probably be very easy and mindless. And probably not using money.
Yeah. Or you buy a machine with a giant tool matrix, but that's like a very
of money,
very expensive solution to a relatively small problem.
Yeah, I know that. So we run Brother machines. I know that I've only seen solutions for the Fanuc, the robo drills, but having a robot that changes out tools doesn't look very difficult, I have to say.
Yeah.
Right?
There's a lot to potentially go wrong.
Like, I think the taper and the pull stud are accessible around the back. So I sort of feel like you could...
No.
Really? Up at the changing station?
There's like a little door behind.
Oh, that's true. You might have to get rid of
Remove
the door.
the
I'm
door.
just trying to figure out, like, I don't know what you'd grab with the robot.
Yeah, that's what I've always wondered.
Yeah.
I guess we need to go
look at the robo drill.
Secret.
Do some sleuthing.
Yeah.
On YouTube.
All right. Trade show.
Corporate espionage.
Oh, we're talking.
Yes. Let's see. So we had an issue where cams were... so we did the long runs. We've run it 3 times now. The first time came back and it was a success. Mostly, there were some cams out on the tray, like finished machine parts on the tray where only stock should be. I had added a coolant blast when it goes to drop the cam in the bucket, and I think the coolant was every now and then flinging the part out of the bucket. So we updated our drop program a little bit. So now it opens the gripper, it rapids down about an inch.
Yep.
I was sort of thinking to like fling it down, but also to get the gripper jaws below the rim of the cup, and then it turns on the coolant for a second. So I think the part's more likely to fall out before the coolant comes on.
Yeah.
Also, the coolant shouldn't blast it out of the cup. The waste there, probably a few things. One, definitely we didn't have any defects that were caused by it, but if a part ended up out on the stock,
where you're trying to pick something up,
trying to pick something up, that could be pretty bad. Probably not catastrophic, but so preemptively avoiding that. And then also when you open the door to the machine, fishing around for finished parts is definitely wasted motion, wasted human potential, all that. And I would also say every time something is out of the ordinary with these things, you end up spending like a few minutes kind of looking around. It's like, did that damage the vise? Did the gripper finger get damaged? Like, what is causing this problem? Because you weren't there to see it. And even if we had a video camera, going through footage is going to be time spent. So like having these things just super, super reliable, has been, I don't know. It's funny. Everyone talks about like with automation, it's about reliability, not speed. And you're like, yeah, I get that. Also, I would like it to go fast. And then I just feel like every failure you see, your appetite for speed, like your desire, your need for speed, as it were, goes down. And you're just like, man, if I just knew this would run well, that would be huge.
Yeah.
Let's do that.
Totally. Side note, did you ever implement the parts counter?
No.
Oh.
Yeah, not yet.
Cool.
It's still on my list. Back to our last episode of mismatched runs between the Kanban and what the mill makes. Now that we're making, like, now the one program makes 80 parts. If we only need 32 at the moment, I need to implement a way of doing that.
Yeah.
So it will happen.
That's your purpose for the parts counter, is primarily to suppress overproduction, not just to count.
I would like both. Separate questions. One is sort of more of an analytics question of like, it would be interesting to be able to go back and know how many of each part we've made historically.
Yeah.
I don't know. I can guess at it. Yeah. And then the other is more for suppressing overproduction.
Yeah. Interesting. Because you run a finite number of programs, like pretty finite, it'd be pretty straightforward for you to assign a variable counter to each one.
Totally.
And at the end of each program, have it right.
Do you have good documentation on all those macros and how they're used?
Which macros?
Like in our machines. All the macro variables. Oh, sorry.
I mean, I think it's in the manual. Like, what's for what?
What's for what is free, but then some of them are used across different programs. And so right now and I should really do this before I start making more programs. Just having a like single point of truth for what macro is used for what. Like these macros can be overwritten by every single program, like these macro variables. And then these other ones are used to count our parts. So it'd be a shame if I wrote a program that used a macro variable that had previously been intended to be a counter.
I think you would just write it to one of the user definable macro variables.
Yeah.
And just find one like that's empty.
Right. I just need better documentation now of which ones are empty, which ones are being used for the different things.
Right. But I guess I'm just saying, like, just going through them, there's vast swaths of empty.
Yes, for sure.
And the only real macros we use are the probing and tool setting for the most part. And then the ones you've written. Yeah. And you know which ones you've written. So it's pretty.
Or do I?
You can find out.
Yeah, for sure.
We've been picking away over the last week on our new trunnion designs.
Okay.
And as of yesterday, finished the tables for them, which is the most complicated part.
Very cool. That's the actual trunnion table.
The actual trunnion table.
Oh, nice.
They were a bit of work. There's a lot of detail, a lot of holes that have to be precise.
Okay.
But I'm very excited. I think they're pretty flat. I think they're going to be pretty rigid.
Yeah.
I'm second guessing my end support design and whether the whole thing's going to be rigid enough.
Interesting.
We'll just have to wait and see. If it's not, maybe make a new like end plate for the rotary end with some gussets to like kind of stiffen up that junction a little bit, but we'll see how it does.
Gotcha.
Yeah.
Interesting.
Right now the far end is just going to be a pin, like 3/4 inch pin in a bushing sleeve to like a vertical stand, but it's all just like 1 inch thick aluminum. It's not anything crazy. And I was like laying in bed last night thinking about the end support that Brother provides. It's like this big cast thing with like a giant bearing, and I'm like, is that necessary? Are we gonna be fine? I don't know. We'll see.
That has a big break in it too, right?
Which?
The Brother one.
A big break? Oh yeah, but even without the break, like it's a significant thing with like probably 100 millimeter diameter bearing taking the load.
It might be one of those situations where like I've crashed our fourth axis, not super hard, but definitely it's happened and it's fine, right? Maybe yours just won't be fine if you crash it.
That's possible. Yeah.
Like you might just exceed the like pressure of the
Yeah.
materials spread over such a small area.
I'm not super that's definitely possible. I'm not super concerned about that. More what I'm concerned about is just like small, like just general rigidity to handle machining loads.
Yeah, how do you deal with preload on a bushing? Or is it just like a super tight fit?
I just got precision ground stock or precision ground rod.
Yeah.
And then the bushing is the bushing.
Gotcha.
More what I'm thinking is, so it's constrained in Z and Y by that end table, or by that end support and the pin through the bushing. The whole thing in X.
I see what you're saying. Because both ends are sort of a thin plate that carries it across.
Yeah, it's kind of like hanging from these two plates.
Yeah, because in Z and Y it does seem...
I think it'll be pretty fine. Yeah.
Okay, that makes sense.
It's not super well constrained in X, except for by the butt joint of the end plates to the table, to the trunnion table.
Yeah.
And so the question is whether those have enough rigidity built in to like handle that.
I guess you'll find out. Yeah, that seems pretty addressable if it is an issue, right? You could change out those end plates to steel. Are they steel?
They're aluminum right now.
So you could go to steel or something.
I could go to steel or
add your gussets.
Or add gussets.
Yeah.
It might be totally fine. Like it's an inch overlap. So 1 inch by 5 inch butt joint.
Okay.
With dowel pins. Like, it's probably gonna be
interesting.
Fine. But
yeah.
Cool. Until you've tried it, it's hard to know.
Yep.
And I've certainly had things go wrong, or I've under designed things in the past that I thought were gonna be fine. Interestingly, I cut them with spanning 2 orange 6-inch vices, and realized after everything was said and done that I never clamped one of the vices back to the table, and it was just loose,
floating around,
just floating. But it's heavy,
right? Yeah.
And the part itself was pretty rigid.
Interesting.
And it did the job.
Very nice. So is that your new SOP?
Yeah. It was kind of funny because after the first op, I pulled the part out, and I had initially like trammed in the vices. They were these step jaws.
Okay.
I'd trammed, and so I bought these vices secondhand. Someone had cut steps into the hard jaws.
Oh, interesting.
And they were all kind of mismatched, I think. And so like I'd trammed it in on the step jaws, and I'd checked the faces of the hard jaws, and they were not perfect.
Okay.
And so afterwards I went back to check it before flipping them, because they were going to go into the next step down. And I was like, wow, they're perfect. I wonder, that's odd. They're perfectly in line. And didn't think about it anymore.
That's very funny.
Clamped everything up. And
nice.
I think the way I did it, it shouldn't matter, because all the critical features were done in that one op. So it's self-aligned.
Yeah.
Yeah.
It was very interesting. Speaking of gussets and rigidity, do you see Grimsmo's changing out the spindle on his Kern?
I've not been following things closely.
He posted a very cool photo. It might have been just in his Instagram stories, up into where the spindle came out of. And it's this just like a tall, I think they're built out of aluminum if I'm not mistaken.
Yeah.
A tall like box, but the inside is just like riddled with gussets welded in, which I thought was fascinating.
Interesting.
Yeah.
I was very curious too when I got the first Brother machine that I have. I'd had like kind of more traditional casting, like just throw more iron at it kind of machines.
Yeah.
And looking underneath those machines, it's just like this crazy web. The Brother machines, just crazy web of gussets and holes, and it's like looks more like something you'd imagine seeing in an airplane than a machine tool. I mean, it's cast, but it's still like there's a lot of removed material, a lot of empty space, and a lot of webbing, which is cool.
Yeah.
Yeah.
Empty space is good. Basically, any material on your neutral axis is basically waste.
Yeah.
I mean, unless your inertia is, or the internal damping is probably a factor.
Mm-hmm. Yeah, and I have an old book from Lincoln Electric Company on. Okay. It's called Design of Weldments.
Oh, cool! Very cool.
And a lot of what it focuses on is kind of the transition from casting to welding for a lot of these big, machine structures and stuff like that. And you can really get away with a lot less material to do the same job with a welded structure. I think there's
Because?
Because of the limitations of casting, I think. And
just like flowing thin
flowing and creating your forms and
Interesting.
Draft and all that. And
Yeah.
being able to pull the two halves apart when everything's done, or the two halves of the form.
Right.
So yeah, anyway.
Interesting.
Welded stuff's cool. As long as you machine it after.
For sure. So we got a recommendation or a lead from Blackwell.
Yeah.
What's his name on Instagram? Blackwell
Engineering, I think.
Engineering, yeah. Makes cool laser plates. Sent I think I sent it to you, a machine to make pins.
Mm-hmm.
So we've been hunting. It just seems obscene to make the pins we're making on any like machining center, whether that's a mill or a lathe.
Yeah.
It's just like such a simple part, minimal machining, minimal requirements for precision.
Yeah.
So like dedicating a $100,000+ machine to make these things just seems messed up.
Mm-hmm. Especially if it doesn't do it faster than what something else could do it.
Yeah, and so the machine he sent, I really liked the design. It was basically, and the most important thing, honestly, was just actually seeing that these machines do exist, and then getting the name for what people call them in industry.
What do they
It was
call
something
them?
like a double header pin chamfering machine or something like that. I really liked how it approached it because it holds one pin and then has counter rotating heads that engage it at the same time. And so you don't really need much rigidity in your fixturing.
I didn't catch the counter rotating part. That makes a lot of sense.
Yeah. So like your clamp doesn't really need to clamp that well. The one that I saw, or the video he sent over, had a chute that already had pre-cut blanks, but I don't think it would be a substantial difficulty to change that out to something that's cutting them right there. But either way, it looks very simple, easy to build, but I don't know that I need to build one. I suspect someone has one either that they're selling or that I can buy for a pretty good price.
That one didn't face, right? So
I think it did.
Oh yeah?
Well, maybe not, but I thought the form tool, because it's a custom form tool on the ends.
Yeah, I
so
guess
I think
you could face with it.
Face and chamfer.
Interesting.
Yeah. Anyway, so I need to find someone with one of those machines who wants to run pins for us, or just buy one.
Yeah.
Even if that's $10,000, $15,000.
Right. Over the life, that's kind of nothing, probably.
Yeah, I think so. I do want, and we might build one in house. It just seems a little bit. We don't need another project, but it looks pretty doable. And I just want to design around quick setups for different lengths.
Yeah.
And even if you could program that in, it would be pretty sweet if it could make different lengths alternating or something. But also diameter. It would be nice to be able to change diameters. Yeah. Maybe not as easily, but like just a change of the jaws or something and a change of your cutter. Feels like. So anyway, just putting some thought into that ahead of time of how we're going to do those tool changes.
Yeah. Did you do any more research along the lines of the cam-driven Swiss?
No. Yeah, maybe that's
I don't know. It might not make sense, but
right. There's definitely a lot of them,
but it might.
Yeah. I don't know what wastes are we fixing? I mean, there it's sort of like a TOC question, right? Theory of constraints. We have a bottleneck on our mill, and we're trying to get parts off of the mill onto other equipment that are easy to do, and the pins are like really ripe for that because they're so simple.
Yeah, it might also just be over processing. Like you're doing
That's
a lot
true.
of
We're
extra,
cutting the parts, then we're manually loading them into a tray, then the machine comes and picks them out of the tray.
Yeah. I think that's kind of the main thing.
That's probably true.
A lot of extra handling.
Yep.
Extra machining. Mostly extra handling, but
yeah, true.
Yeah. So another issue we were having again with our job tracking slips was we basically had 4 lanes, one for each of our CNC centers. So we had a lane for a lathe and then each mill.
Yep.
And we didn't have a lane for odd job manual stuff.
Oh, interesting.
Or like the sawing that we do for you.
Yep.
And so we were just like, where do we put these slips? Like they need to get done.
Interesting.
So for a while we were putting them on our whip board, but we were finding that we were all ignoring them. So then we just added a lane. Basically.
That is like MISC?
It's manual / saw.
Okay.
Manual. So like we had a manual machine job that came in last week where someone just wanted some plates modified.
Gotcha.
Kind of a thing I probably wouldn't normally take, but they're a good customer who sends us a lot of CNC work as well.
Gotcha.
And they just kind of needed this little odd deal done, like some laser cut random
Want to keep
stuff.
them coming to you.
Yeah. Good learning experience for one of the employees to do
cool.
it. So at the moment it doesn't go onto our main board. It's just on our staging board, but that's enough to kind of like see it. And then pretty much it doesn't go through any of the other processes on our main board. So it doesn't matter.
So I don't quite understand. Why isn't there a lane for sawing regardless? Because a lot of parts do need sawing.
Yeah, it's not a lane. It's a column. So it's a step in on a lane.
And you can't just put a lane up. I'm not thinking of the specifics of your board, so maybe.
It was just not the simplest solution. The simplest solution was a lane in our pre-staging.
Gotcha.
And that's all.
I guess because it doesn't even need to, because the main purpose of that board is to make sure things stay busy, the bottlenecks, right?
Yeah.
And so if it's missing all those bottlenecks, it's kind of irrelevant.
Yeah, basically.
Interesting.
Yeah.
Very nice. We pulled the trigger on a Freddy.
Ooh la la.
Yep. So excited about that. It's funny. I don't know how to feel about it. I don't feel like it's the best use of money. This feels very much like I really didn't like doing that thing, and I didn't really feel comfortable asking anyone else to do it if I really didn't like it.
Yeah.
And so, again, I don't know. Like, just for us, it seems like a great, like where you're at, it makes tons of sense. We have one machine, right? So it just feels like it's going to be sitting there a lot, but I am very excited about it.
Yeah. There's questions about contamination of your coolant if it's going in there, but I think it's good to remember that it's also just a vacuum.
Yes.
Like, so we don't use ours as a general vacuum, but, for any situations where you have chips, like, I guess it just took me a minute to be like, oh, we don't just necessarily use this for cleaning out the sump. We can use it to clean up the whole chip tray where chips end
so
up.
I'm excited about that because right now it's really messy and there's no good way of cleaning it really. So I'm excited about that. I'm just very excited about having that machine in the shop because it's a job that I just put off all the time because it's very unpleasant. Right now we have sort of like pond filter mats in the back of our machine. They've been very successful at keeping fines out of the sump. Yeah. But when we actually want to do like a deep clean of all the filters and stuff, it's horrible. Yeah. Because you have to like pull them out. They're dripping with coolant. Yeah. They're covered in fines. Get them all over your hands. They're like dripping off and it's gross. Like
metal fines and coolant all over your hands is the worst. It's like sharp, and it's sticky,
and you can't really brush them off because then sometimes they'll cut into your skin. It's very unpleasant. So
you just vacuum them out now.
I think that's what we'll do.
Yeah.
We might just let the fines go in the tank and then vacuum them out, or I might take out we have a really fine filter under that thicker mat.
Yeah, but you could just vacuum the mat now. Potentially.
Yeah, that's a good point. Yeah, so we'll see how all that gets integrated, but it was a gross job and I hated it. So it's felt a little funny spending that kind of money on
a vacuum.
A vacuum that, like, again, if we have 10 CNCs or 3 CNCs even, it just feels like it's a task that only needs to happen like 3 or 4 times a year currently. Like we do a lot of scooping, but we don't really need to clean out the sumps. That's going to become more frequent. So it just seems a little weird to spend that kind of money fixing a task that needs to happen so infrequently.
Yeah, I think as your volumes increase, you're going to need to do it more.
Yeah. So anyway, really excited to not every time I walk by it lately for the past like 3 months that I've been putting it off. I'm like, yeah, anyway.
Well, I'm out.
Cool. I'll just rip through a couple here. We have a new like PO terms from lawyers to drop in for big orders. And so there wasn't really a place for them to live. So I just made a little cardboard shelf right above where our big orders are processed.
Wait, I'm not following. Where do these end up?
We pack them in with packages that are going to resellers.
To resellers.
Resellers or to OEMs. So people who are using it for whatever purpose they want, we're basically saying we're making no claims.
Gotcha.
And you need to talk to your insurance company about your particular use.
And this goes, so when you say PO, I think purchase order.
So this is sort of tied to that. It's like, these are the terms of this deal.
Wouldn't that be something you'd want on your quote?
I think you want it everywhere. Yeah. So, so they're kind of going everywhere.
Interesting.
Yeah. So made a little place for them. Before that,
you're sending a paper copy with your parts.
Yeah. Before that, every time we would have to go on the computer and print one out, which is definitely more in like just in time. Which is, now that I'm saying that, I wonder if we could automatically trigger something, because you are at the printer anyway when you're at the shipping station anyway when you're making these. So if we just integrated it into a workflow, so maybe this shelf is.
Do you have a packing slip?
Yeah.
You could integrate it into your packing slip template.
Yeah.
Maybe.
That's a thought. It is in, I'll have to look at that. It's in ShipStation.
Uh-huh.
And the template we use right now is the same one we use for direct to consumer orders. So maybe we need a second template that's for bigger orders and has this integrated.
Uh-huh.
That would be a nice fix. So anyway, we made a place for them to live, as we're talking about it here. Maybe that's not the best improvement.
It's good for now.
It is good for now. It also took 5 minutes with cardboard. So did that.
Very good for now.
Let's see. Reordered the items on the shelf near the shipping area, because the extra envelopes were up high, like you had to stand up on your tiptoes to like reach them. And that's the thing we replenish the most. And so then I was looking at all this space under the shipping station that has like this and that on it, and so I just switched all that, and so now the items that we get frequently are just much more ergonomic to get. So that was a nice one. And then something we're struggling with right now is our whole workflow around big orders. We have enough big orders now at the same time that Sam had the brilliant, you would think obvious idea of naming each order or something, like having a standardized way of referring to each order. Because we're always like describing, the one where,
right,
like the one with the long straps or the one with this color.
Right, because you don't have like a job numbering system
We do, so we could just use that. It's not that easy to remember, I think, for me.
That's true. Yeah, I mean, we still refer to orders generally by customer.
I mean, there is a question of why do we even have to refer to the orders with each other? That implies already some sort of
confusion,
room for improvement on the system as a whole. But that whole workflow is pretty hodgepodge, I guess. It is an exception. It makes sense to build a different sort of routing through the shop. Not really routing, but the problem is this: if we do a lot of orders that are sort of in the like 4 to 12 piece range for like direct to consumer, and all of our Kanban quantities at the assembly stations are optimized for those quantities. If we drop an order for 500 on the assembly area, and we rip through that, it wouldn't be ripping through, firstly, so delay any direct to consumer orders substantially. So we really need to break it out. And then the other issue is it will deplete our inventories because our inventories are designed for much lower quantities. And so we need a way of taking bigger orders, breaking them out into bite-sized chunks, and then also triggering triggering excess inventory to arrive at the assembly area to account for the fact that it's a big wave hitting it. And that is to make up for the fact that we have high latency between triggering orders for paint and them actually arriving at the, like, if that didn't exist, right, then you wouldn't need larger quantities there, but it does exist. So that's what we're doing at the moment.
So I'm not sure this is the answer, but thinking back to the job shop lean methodology, I think it's really tempting to think about running all this stuff through a single flow. Because conceptually it's the same part.
Right.
But I wonder if there could be some advantage to creating separate cells for different volume sizes.
That's an interesting thought.
Probably not, obviously, at machining, because you don't need to buy a separate mill for that whole thing. But
any excuse to buy a new mill.
But and you're space constrained, so this is challenging. But if you had a separate assembly station, that was just for big orders and kind of had its own Kanban quantities, and you figured out how to mesh the pull from the upstream processes, and you could just like add labor to that one when you needed it and not when you didn't, and not interrupt anything else, or try and be, partitioning these into small jobs to fit them into this other workflow. I wonder if there could be some benefit there, because like duplicating your assembly fixtures is not a huge lift.
No.
And they could potentially flow through other, like maybe the sewing machine, the flows come back together.
I think there is substantial advantages to production leveling in general. Like Toyota runs their lines, like they'll run one sedan, one truck, one station wagon, one sedan, one truck, one station wagon, instead of breaking it out across different lines. So I think there is reasons to keep them combined, but there's also reasons to not keep them combined. And it's an interesting way to delineate.
I think there's a really big difference there. Which is that they are making to stock. And you are making to order. And that your demand is not level. Right? So like they're able to level that based on a downstream buffer. You don't have that option right now.
Unless, we could add it.
You could add it. You could add a big buffer. Or you could, add that buffer in your terms, which you're kind of doing right now.
Right. We're saying we'll deliver 100 a week, basically, or something like that.
Yeah. But it seems like as much as like the mixed model production makes a lot of sense, I think there's also some advantages to separating out these lines when there's, if you were able to deliver these large orders on a shorter timeline, you would have happier customers and you would have more cash on hand. So I think there are some advantages to not treating them as the same flow line.
That's true. I'll have to take a good hard look at that. We also have like inventory floating all over the place. Like that's queued up for assembly. I just went away for 5 days. And so I got ahead on painting to make sure that we could hit those deliveries, because I'm the only one who paints still. Anyway, so I've been running into all sorts of issues with where to put the stuff, and luckily we make a tiny product. I can't imagine if we were making like grills.
Right.
It would be crazy.
I'm just gonna stick 600 grills over here. Totally.
So
anyway, interesting thought.
Time to wrap up here.
Indeed.
Thanks all for listening.
Yes, we'll have more next week.
We sure will.
Always more continuous improvement every day.
Never ends.
All day.
Have a good one.